Greetings, everybody. We are going to look at Fisher projections one more time. Not Fisher, Newman projections one more time. Because last week we didn't have any eclipsed examples. And a student asked me, how can I quickly decide if it's going to be eclipsed or staggered? And I sent her this picture over the weekend. Eclipsing happens when you have a wedge right in front of another wedge and a dash in front of a dash and a non-wedge, non-dash in front of a non-wedge, non-dash. Same story here, it looks flipped. Staggered is when you alternate, this wedge bisects this in half. That's nice staggering. And if this doesn't match a non-wedge, non-dash on the other side, it's not going to be eclipsed. It's not going to be eclipsed. That's right. It's going to be staggered. So it looks like I picked the first picture and I made a molecule out of it and I made a question out of it. It's a small typo. Should have the letter T right here in front. And we did the numbering off screen. And we started answering the question before I realized we didn't have a video going. So here's the start. You do your circles. And try to remember which bond I asked you to draw first from last exercise. And it was the one on the front carbon that wasn't a wedge and wasn't a dash. That way you know it's a straight up or straight down. And we got our green eye looking this way. I'll just use an arrow. You were told to look with your eye there. So I drew the bond that's going straight below my eye. And there you have it, carbon 6, 5, 4, 3, 2, 1. Little extra action there. And there. Okay, and go to the back carbon and do the same. It'll be this group right here. 8 carbons and then a 9th carbon. I'll do it in blue as well. Remember, you don't see the whole bond on the back carbon, and it's eclipsed, so it's right behind this group. 1, 2, 3, 4, 5, 6, 7, 8. 9. Should have been 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. And now do the, we got to get on over there. I'm not going to video myself walking over to the screen, but I'm putting my eyeball right here in my mind. I'm kind of walking. I'm using my right hand to get to that isopropyl right there. That's to my right. If I'm standing over there, every wedge is to my right and every dash is to my left. If I'm standing where I'm supposed to be standing. So right and a slightly above my eye is an isopropyl. We'll do that in green. No, we use orange. Isopropyl, this is the front carbon, evenly spaced up there, and then an H to my left. All the dashes are to my left if my eyeball has to be put on carbon 7 like that. Wedge to my right is a CH2 and a neopentyl. It'll be tricky drawing a neopentyl, but I got it. There it is. Right behind the isopropyl. Here's the isopropyl. There's the neopentyl right behind it. Isopropyl, neopentyl. Isopropyl, neopentyl to my right. And then I've got an isoheptyl, 2, 3, 5, 6, isohexyl. And that gets drawn with 5 in a row. 1, 2, I don't like the way it started. Right behind that H. 1, 2, 3, 4, 5, and then the V. Congratulations. And I wanted to make this exercise a little easier, so this is also answer C. What? How do I know it's answer C as well? Bulkiest group on the front carbons right here. Isopropyl, it's got a branch immediately. No other group on the front carbons branched at all. And then neopentyl has a branch only 2 carbons away from the ball, whereas the isohexyl has only 1 branch and it's further away. So neopentyl is much bulkier than the other, and they're right on top of each other. This is also answer C. You'll see that on the occasional exam too, where you didn't have to rotate to get one of the other answers.
How come, like, I don't understand why you're putting some of them like attached in the middle, and then
Some of them attached in the middle. Over here,
yeah, like, why are those attached in the other corner?
well, the front carbon, you see the whole bond because your eyeball's here and the bond's right in front of your eye. The back carbon, carbon 7 is in the way, so you don't see, here's the carbon. You don't see the whole bond because it's hidden by the carbon 7, which is right there. So everything up to about right there is hidden by carbon 7. You don't see it. You only see the end of the bond. 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 Because that's off the back carbon.
Oh, so everything on 7 looks.
Yes, you see everything on 7 because your eye is right in front of it. You will miss nothing. But if you have objects in front of objects, you don't see when there's an object right in front of another object. So we don't see the whole bond, is what I'm saying. And then, so I'm going to get rid of C. We have answer C. We got the, oh, I'll move the B over here just so we have a little more space. And you decide which carbon you want to rotate. I think last week we rotated the front carbon. I'll rotate the back carbon this week. Just so you know another approach. I'm going to copy the front carbon. Didn't do a great job. 1, 2, 3, 4, 5, 6. Is that right? 1, 2, 3, 4, 5. One more, 6. And we got the orange H. And the orange isopropyl. I got to rotate the back carbon how many degrees to get the neopentyl as far away from the isopropyl as possible. Right now it's right behind it. 180. So the neopentyl will now be 180 from the isopropyl. You will only see the end of the bond. And you better rotate the H 180. No, not the H. The neopentyl and the isohexyl 2, 3, 4, 5 V. And the long chain of 9 to 17. Here we go. 9, 10, 11, 12, 13, 14, 15, 16, 17. 9, 10, 11, 12, 13, 14, 15, 16, 17. And the bulkiest group on the back is now over here. And they're 180 from each other. So this is the most stable conformation as asked for. And there you have.
You're going to have a sheet for it.
Oh, yeah. Basically, you just need to copy the A and B answers. There we have it. So I'm going to close the video now. And I don't think anything else has to be done. Adios.